Okay. So lecture number uh, lecture number 5 and lecture number 6 are lectures about the measurement. Now we will continue with the analysis. Since we already have these new variables with row scores, or with average scores, or with indexes, or with z scores, or t scores, or factor scores, we can continue with analysis. And the first step of analysis are so-called descriptive statistics, or frequency distributions with descriptive statistics. And we will start with frequency distribution and corresponding descriptive statistics for different scales. Descriptive statistic for nominal scale, for ordinal scale, and for interval scale. So first of all, I will close this presentation about factor analysis, and we will open next presentation about descriptive statistics. And we will start with descriptive statistics for nominal scales, nominal variables. I will work directly in PSPP. Here, we must choose analyze, after that descriptive statistics, after that frequencies. And here we already have used this this analysis. So I will press reset to start from the beginning, and I will switch to presentation to see which variable will be the first. So the first variable is what are the major source of stress in your life, I think. So here, what is the major source of stress in your life? This is enough, but here it will be recommended, or will be good to uncheck these check boxes here before continue. I will check them, and then we'll press OK. And then let's see the results. Results are here. So this is nominal variable. We have different categories. These categories show only difference, but here we have no order. We have no numbers, only difference between different categories. And in this column, in column frequency, we can see how many persons or how many individuals are how many individuals correspond to this answer. So for 224 individuals, work is main source of stress in their life. For 12 persons, spouse or partner is the main source of stress in their life, and so on. After that, we have two columns with percent and varied percent. Difference between is due to missing. Here you can see that 17 persons are missing. They didn't answer this question, and these 17 persons are almost 4% of all. 4% of all 439 persons at all. This column percent includes missing. Missing are included when the percent is calculated. This column, valid percent, excludes missing. Missing are excluded when valid percent is calculated. And this is the difference between these two columns. So work is main source of stress for 51% of all 439 persons, but work is main source of stress for 53% of persons who answer this question, and they are 439 minus 17, 422. So 224 persons are 51% from 439, and for 224 persons are 53% from 422. This is the valid percent. The last column, cumulative person, this column is irrelevant for the nominal variable. So when we analyze nominal variable or nominal variables, we must skip this column. And in presentation is shown the same. Percent with missing included, valid percent with missing excluded, and skip column cumulative person. After that, descriptive statistic for ordinal variable. Oh, sorry. We can make charts here. In PSPP, there are not many options, many possibilities for charts, but charts exist. And if we repeat again, analysis descriptive statistic frequency, here is the bottom chart. And usually for nominal variable, we use pie chart. So I will choose here pie chart, then continue, then OK. And here is the pie chart, different categories and different slices of this pie for different percentages. In SPSS is similar, not exactly the same, but similar. We can choose pie chart, and here is the pie chart. This pie chart and this pie chart are the same, but this pie chart is rotated. This pie chart starts here in 12 o'clock, and this starts here in 3 o'clock. This is the difference. This is rotated pie chart. But they are the same, only are rotated. Only one is rotated, comparing to other. Okay. These were the descriptive statistics for the nominal variable. Now, ordinal variable, higher educational level of these persons. So, again, analyze, again, descriptive statistics, again, frequencies. Source, I will move source from right to the left, and we'll choose highest level of education. Where is this? Oh, source education. Okay, this is education. I will move education from left to the right, and I will change the chart. Usually, for ordinal variable, we use bar charts. So I will uncheck pie chart and we'll check bar chart. After that, continue. After that, okay. Here is the result. The interpretation of descriptive statistics of ordinal variables is almost the same as nominal variables, but here we can analyze or can make interpretation of this last column of cumulative percent, and cumulative percent shows percentage of persons who have values of this ordinal variable which is equal to or less than the value in the corresponding row. So, for example, here we have 59%. The value on the corresponding row is some additional training. And here we could say that 59% of persons have education, which is some additional training or less some additional training. Because this cumulative percent is sum of valid persons. Here we have 0.5 plus 12.1 is 12.5. Actually, 0.5 plus 12.1 is 12.6, but because of rounding of these numbers, there are sometimes, there are not always, but sometimes there are errors which are due to rounding of numbers. After that, 0.5 plus 12.1 plus 19.4, the result is 31.9, and so on and so on. So this percent here, 59%, is the sum of first 4%. 0.5 plus 12.1 plus 19.4 plus 27.3, and these are percents of first four categories. So 59% are primary or some secondary or completed high school or some additional training. So we can say here that 59% have some additional training or less than some additional training. And here we could see this bar chart with different educational categories and number of persons in each category. So, okay, bar chart again, and the last and the most difficult analysis. This is descriptive statistics of frequency distribution of interval variable. And here we will analyze H. So I will make this analysis in PSPP. First of all, choose analyze descriptive statistics, frequencies. Again, I will move education from right to the left, and we'll move H from left to the right. But now this is not enough, because when we analyze interval variable, interval scales, we can calculate different descriptive statistics in SPSS. These different statistics, different descriptive statistics, are grouped in different groups. In PSPP, they are not grouped, but they exist. The same descriptive statistics exist in PSPP. So the first group are the descriptive statistics for central tendency, or measures for central tendency. And here we have three main measures of central tendency: mean or average mean, but the word average is skipped, median, and mode. So I will choose the same in the PSPP. Here we have mean, median, and mode. They are the same, but are in one list, not in different groups. The next group are the measures or descriptive statistics for dispersion. And here we have standard deviation, range, minimum, maximum. I will choose them in PSPP. Standard deviation, minimum, maximum, range here. Now I will choose another one, variance, because this is our first time of calculation of these descriptive statistics. We will see that variance is difficult for interpretation, and after that we will skip it. But now I will check also variance here. The next group is here, measures for distribution, or measures for shape of distribution. And here we have skewness and kurtosis. And I will check here skewness and kurtosis in PSPP. And the last group are measures of percentiles or percentile values. And here I will check quartile. I'm not sure that quartile exists. Yes. Quartiles do not exist in PSPP, so I will not check them because they are not there. Okay. So I choose different descriptive statistics, and I will change the chart. I will uncheck bar chart, and will check histogram. We already made histograms, but here for the interval variables, the appropriate chart is histogram. So press continue, press OK, and let's see the result. The results are here. Now here we have new table statistics with different descriptive statistics there. First, descriptive statistics for central tendency or measures of central tendency. Mean. This is average mean. So we could say here that average age of this population, of this 439 person, is 37.4 years. This is their average age. After that, median. Median means that we have ordered all persons, and then we took the person in the middle, and his or her age is 36 years. That means that half of our population, half of these 439 persons, are less than or equal to 36 years of age. And accordingly, other 50% of our population are greater than or equal to 36 years of age. And the last measure of central tendency is mode 21. 21 means that most of these persons are 21 years of age, or the greatest number of persons are on 21 years of age. And here we could see that this is correct because 22 persons are 21 age of years, and this frequency 22 is the biggest frequency. Most persons are 21 years. So these were the measures of central tendency. The next group are the measures of dispersions. Here we have two two measures. First is standard deviation. Standard deviation, this is average deviation from the average mean. And here we can calculate again we can calculate mean minus 1 standard deviation and mean plus 1 standard deviation. So the average age is 37.4 minus standard deviation 13.2. The result is 24.2 and mean 37.4 plus standard deviation 13.2. The result is 50.6. These numbers show that most of the persons, the biggest part or the biggest percent of the persons of our population are between 24 and 50 years of age. So 24 is here, 50 is here. We can calculate the total number of persons between 24 and 50 years of age. And of course, we can calculate the total percent of people between 24 and 50% of 24 and 50 years of age. And we will see if we make these calculations, we will see that indeed in this interval there are the biggest frequency and they are the biggest percentage of population. So this was standard deviation. Plus and minus 13.2 years of age. Variance. Variance is squared standard deviation. So if we take 13.2 and multiply by itself, the result is equal to the variance. Variance is difficult for interpretation because standard deviation measures deviations in years. So variance will measure the same deviation in square years. And this square years is very hard for the interpretation. So in next analysis, I recommend to skip this variance and to use only standard deviation as measure of dispersion of deviation. So the first main indicator or the first main measure of dispersion is standard deviation. Other measure for other measure for dispersion is range. Range is the difference between smallest and largest value. So youngest person in our population is 18 years of age. Oldest person is our population is 82 years of age, and the difference between 18 and 82 is exactly 64 years. So the oldest person is with 64 years older than the youngest, or opposite, youngest person is 64 years younger than the oldest one. This is the range difference between maximum and minimum, but difference between empirical maximum and empirical minimum. In the previous topic, when we talk about normalization, we use theoretical maximum and theoretical minimum. Here, this minimum and maximum are empirical minimum and empirical maximum. And these were measures of dispersion. The third group are the measures for shape of distribution. And in this group, we have two measures, skewness and kurtosis. So here I will draw some pictures to explain what does that mean, skewness, and what does that mean, kurtosis. So skewness, form of distribution. There are three possibilities. First is symmetry, and other two are skewed distribution. So here we have symmetry, but we could have so-called right skewness or so-called left skewness. In this case, right tail of distribution is longer than left tail of distribution, and the distribution is right skewed. But in this case, in the opposite, left tail of distribution is longer than right tail of distribution, and the distribution is left skewed. So this measure of skewness here, skewness 0.6, the sign of this measure, of this coefficient, shows the direction of skewness. For a right skewed distribution, the sign of coefficient is plus. For left skewed distribution, the sign of coefficient is minus. And here, when we have symmetry, then the coefficient is 0. So here we have 0.6, the sign is plus. That means that we have right skewed distribution, but the number, the value is small. 0.6 is small number. That means that there is, of course, right skewness, but this right skewness is not so big. There is a small right skewness, right skewness. The other measure or the other indicator is about kurtosis. Kurtosis means where is the top of this distribution, and we can have two possibilities. First one, sharp distribution. The top of distribution is very high. And the second possibility is flat distribution. The top of distribution is very low. And also, we can see the kurtosis of distribution by the signs, of coefficients. So here, kurtosis, we have minus 0.2. That means that we have flat distribution. When the distributions are flat, the sign is minus. When the distributions are sharp, the sign is plus. So in our case, we have minus, so flat distribution. But again, this value is very small. 0.2 is very small. That means that the top of distribution is very close to the top of normal distribution. Here, normal distribution, we already talk about this normal distribution. Normal distribution has 0 as coefficient of kurtosis, and also normal distribution has 0 as coefficient of skewness. So when the values of these two coefficients are close to 0, this also indicates that the distribution is close to normal, to the normal distribution. So first we made histogram with a normal distribution on it, and compare empirical distribution with normal distribution. Second, we calculated a percentage between percentage below the norm, in the norm, and above the norm. We compare these numbers with 16%, 68%, and 16%. And in this way, we also compared empirical distribution with normal distribution. The third way for comparison of empirical distribution and normal distribution is to compare skewness and kurtosis with 0. And if these two measures are close to 0. That means that the empirical distribution is close to the normal distribution. So here, let's repeat the analysis again. Let's repeat descriptive statistic frequency, and here press the bottom chart and check superimpose normal curve, then continue, then OK, and then let's go here. Here we can see that the distribution is in fact right skewed. The right tail of this distribution is larger than the left tail, and we can see that distribution is flat because here we have area which is not covered by these bars. We have empty spaces here below the graphs, below the line. And of course, we have bars above the line, but this coefficient minus 0.2 shows that empty area above the line is larger than these bars, in the opposite. Empty area below the line is larger than these bars above the line. And the distribution is flat, but this distribution is close to the normal distribution because the kurtosis is small and skewness is also small. Now I will switch to the presentation again, and we will show here on the histogram all these descriptive statistics. First, mean, average mean. Average mean is here. The top of the normal distribution indicates the position of mean. Median cannot be seen here on this chart. Mode is here. The biggest or the largest frequency here, 21 years of age. After that, measures of dispersion, range, difference between smallest and largest, between lowest and largest value of this variable, and mean plus and mean minus one standard deviation. This is the range, and here we can see that most of the persons are in this interval. The greatest or the biggest number of persons are here. Of course, outside the interval also there are persons, but their number is smaller, and accordingly their percent is also smaller. These were measures of central tendency and measures of dispersion. Now, right skewness, okay. And here we cannot see the flat distribution, the kurtosis. Now I will show you another chart. Unfortunately, we cannot make such chart in PSPP because this chart is connected to these measures, quartiles, which we cannot compute in PSPP, but in SPSS we can compute them and can make this chart called box plot. Here, this is the box plot. In this chart, this line here represents median. These edges of the box, upper edge and lower edge, they represent so-called quartiles. Quartiles show the particular value of this variable by dividing the number of persons, the size of population, by dividing by 4. So first quartile here show the border between first quarter and the second quarter of persons. This line, median, shows the border between second and third quarters of persons. And this line, third quartile, shows the border between third and last quarters of persons, of population. These whiskers on the top and on the bottom indicates the normal range between the normal interval for this variable. In this case, the normal interval for age, and this point here is so-called outlier. That means that we have one person who is very old, and this person is outlier. Normal range for age is from here to here, but the oldest person is out this range. He or she is outlier. So, okay. So this was the topic about descriptive statistics. Questions? Okay, I will stop recording.